Hi, I'm Dave Tokic, and I'm here to share a little bit about what Algolux is doing for smart optimization for vision systems, and I will be showcasing our CrispML platform. One of the key challenges with vision systems today is the tuning or optimization of the image itself, both for human visual quality as well as for computer vision. What Algolux is doing is bringing the ability to lower your cost, time to market, and improve your system effectiveness for your vision system. And let me share you a little bit about how we do that. So any camera system today typically has a lens or optics, a sensor, and then the image signal processor, which then feeds into the application processor. Unfortunately, when you're getting a development system, it's set to the default settings, which are marginal in terms of the quality of that image, whether it's for human perception or for computer vision. So these systems, or the ISP, need to be tuned to improve that visual quality. Unfortunately, it's a very complex task to do that, involving hundreds of parameters and a lot of manual tweaking of those parameters and visual inspection and analysis to see whether or not it's achieving the goals that you want. For computer vision, it really becomes a critical problem. In many cases, such as in automotive, you're actually trying to save lives and make sure you're avoiding accidents. So the tuning process there, or optimization, is even more critical. As I mentioned, it's a long, intensive manual process, sometimes taking many months and hundreds of thousands of dollars of expense to accomplish. What we're bringing to the market is CrispML, which is a machine learning-based platform to optimize those systems, those ISPs, based on target metrics or KPIs. So providing more of a algorithmic and intelligent approach to doing that tuning process. And so I'm going to show you CrispML in action.
So we do various things. This is just a label.
So what we're demoing on today is a Movidius Myriad 2 hardware development platform, and we've integrated CrispML into the ISP parameters. So let's start a run. We'll call it EVA for the Embedded Vision Alliance demo, and we're going to iterate 10,000 times on the sets of parameters. So we'll create our process. Maybe I'll expand the screen. Let me expand it to a bigger picture here. And we're feeding in these three standard test charts. An SFR plus chart for sharpness, color checker for color accuracy, and spilled coins for texture. And in this particular instance, we've leveraged the Microsoft Skype specification or metrics for their KPIs for certification. So, for example, their targets for the SFR Plus chart showcased here are like MTF30, MTF30 80%, etc. And in this screen, you can actually change your metrics or your KPIs that you're going for. So this is the goal that you're trying to achieve. But we'll leave it at the setting that we originally had. Similarly, for color checker, we have a set of parameters, or KPIs, excuse me, that we've preset with the Skype specification, and similarly for the texture accutance here. So these are the goals that we're trying to achieve. And normally a team would be manipulating the parameters to try to achieve those goals manually. We can also view the ISP's default settings here. For example, in Debayer, here's a few of the hyperparameters that have been preset. Or if we go down to Chroma, for example, here's a few other ones. So this is the preset out-of-the-box experience. So we would run CrispML and it would iterate its 10,000 times trying to find the right set of parameter combinations to achieve the KPIs that I showed earlier. So let's take a look at how we analyze that. So what we've done here is a X by Y of two of the KPIs shown, and we're trying to achieve a goal within this target. So if I turn off all the results, here's the default setting. We're outside that goal. If I turn just our best result on, we do Pareto groups, we're within. And so we can actually take a look at what those were. And in the baseline, we've unfortunately failed. The base settings or baseline settings have failed, and we've passed everything except for one, which is texture accutance. And these are the actual parameter settings that were the results. And we can actually compare and review those results. So if we look at here, this is the out-of-the-box setting on the color checker chart, and here's the color improvement. If we look at our dead leaves chart for texture accutance, we can see the original settings versus a crisp output, and similarly for SFR+. We can show the baseline settings and much sharper results using CrispML. And this only took a run of about 6 hours to do those 10,000 iteration as opposed to weeks or months of manual tuning. The end goal here is reducing your costs significantly, shortening that time to market, and doing better leverage of your resources and expertise to have a much more effective system through use of our platform. So I want to say thank you, and for more information, please take a look at www.algolux.com and see how CrispML can work for you. Thank you.